This will be our lesson on box and whisker plots. So let's start with some vocab. You'll want to write this down on your paper or in your notebook. So the first vocab word is box and whisker plot. And a box and whisker plot is a way to display data by breaking it into quartiles. Another word for quartiles is fourths. So breaking the data into 4 sections. So to do that, we're going to need to know 5 important numbers. These numbers are called the 5-number summary. And they're the 5 important numbers used to create a box and whisker plot. They are the minimum, the lower quartile, the median, the upper quartile, and the maximum. Now, 3 of those numbers you should probably be able to solve without any trouble at this point. The minimum, you know that means the lowest number. The maximum, that means the highest number. And the median is the middle number. So all 3 of those are very, very easy. Lower and upper quartile are just as easy. Something you will want to make a note of is that lower quartile and upper quartile are also sometimes called quartile 1 for the lower quartile and quartile 3 for the upper quartile. That means that the median is also sometimes called quartile 2. So, some notes that you may want to make about those terminologies. So let's keep going. A quartile is 1/4 of the data in a set. So when we talk about quartiles, we will be talking about 1/4 of the data, which is also 25%. Oops, there we go, 25%, right? 1/4, 25%. So that's very important for us to know. And last but not least, this idea of the interquartile range. The interquartile range is the difference between the upper and lower quartiles. So if we take our quartile 3 number and we subtract our quartile 1 number, that gives us the interquartile range, also called the IQR. So a lot of heavy vocab here, but it's not very complicated stuff. So let's get moving to an example. So first thing you're going to want to do is you're going to want to pause this video and you're going to want to put this list of numbers in order from least to greatest. Whenever we find box and whisker plots or create box and whisker plots, it's always helpful to have our data in least to greatest order. So pause the video, take a second, put those numbers in least to greatest order. Okay, so I'm trusting that you paused the video and put the numbers in order. So did I. Here they are. Maybe it'll show up for us. Ah, there it is. So in red, those are our numbers in order, and that's going to help us to do our 5-number summary. So like I said to you before, the easiest number to always find is the minimum, the maximum, and then the median will come next. So the minimum is our lowest number, that is 7. The maximum is our largest number, that's 54. The median is going to be our middle number. So I don't know how you like to calculate the median, that's your choice. But remember from our last video, I counted up how many were in the set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I took that number divided by 2. I got 7. Since it's an even 7, that means there's an even number. Since it's a whole number 7, that means there's an even number of numbers in the data. So I can count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. My median is actually going to be between those two. If you like to just cross off the lowest and highest, that works as well. So I know there are 2 middle numbers. There they are, 22 and 25. To find the median, I have to add them together. I get 47 when I do that. Divide by 2, and that gets me 23.5. Now, since there are 2 middle numbers, notice I drew a line showing where my median would be. That line is very important. I want you to draw the same line. That line breaks my set of data into a lower half and an upper half. Now, quartile 1, which is also called the lower quartile, that's just the median of my lower set of data. So 1, 2, 3, 4, 5, 6, 7. There's 7 numbers there. The middle number is this 4th guy right here. That's quartile 1. Again, there's 7 numbers in the upper half of data, 1, 2, 3, 4. That's my middle number, 41. So that's my upper quartile, or quartile 3. So remember, if there are 2 middle numbers in a set, you draw a line between them, and that will break your set into those 2 smaller sets of data. Then you can find Q1 and Q3. So now I want to plot it on my number line. You're going to want to draw this number line. You can pause the video if you have to do that. I counted by 5s because I knew that I wanted to include 7, and I also wanted to go all the way up to 54. So I numbered my number line by 5s. Now when I plot my numbers here, my 5-number summary, the first thing I'm going to plot is my minimum. The minimum is plotted with a dot. So find where 7 would be. I'm going to jump above the line. I'm going to draw a dot. And then I plot my maximum. That's also drawn with a dot. So that's 54. That's all the way up here. And I'm going to hover above the line again, not on the line. My 3 quartile numbers, quartile 1, quartile 2, and quartile 3, I'm going to plot them with little vertical lines. So I find 18, and I put a vertical line above the number line. I find 23.5, I do a vertical line, and 41, I do a vertical line. Now this is called a box and whisker plot. So these 3 lines, if I connect their tops and I connect their bottoms, that becomes the box. And then if I connect the dots to my quartile 1 and quartile 3 to the other dot, now I've got my whiskers. So something you need to remember about box and whisker plots is that each one of these chunks from dot to line, that's 25% of the data. This line to line, so that little box right there, that contains 25% of the data. That's a quartile. From this line to that line, that represents 25% of the data. And from this line to that dot, that represents 25% of the data. So what it does is it tells us where we have clusters in our data, like right here. See how this 25% is really smushed together? That line and that line are very close. That would be a cluster, so we've got a lot of data in that spot right there. It also shows us where we have more spread out data. So you can see there's a pretty big gap between these 2 lines. So this 25% is pretty spread out. So that's the big idea with box and whisker plots. Box and whisker plots will break it into that 25% data to show us the spread. This is good for the really large sets of data when we really just want to see things like minimum, any trends in clustering, or our mean, okay, and the maximum, of course. Last thing we can calculate is that interquartile range, the IQR. That's just when we take Q3 minus Q1. So we do 43 minus 18. And we're going to borrow. And we get 25. So our IQR is 25. And what that means is, oops, not 25%, pardon me. Let me erase that. That means that 25 data points lie in our box. 25 data points lie in that middle 50% of the data there. We'll talk more about that in class. Let's see one more, because there's one more exception here. Again, remember, you're going to take, I would pause this video and I would absolutely take the time to put those numbers in order. I have mine in order right here in red. This data set is a little bit different because this time there's an odd number of data in the set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the halfway point for 13 would be 7. 1, 2, 3, 4, 5, 6, 7. So if I take a look at that first 8 breaks my data in half. That's our middle number. There are 6 numbers below the 8. There are 6 numbers above the 8. So I have a median here. My median is 8. My minimum is 2. My maximum is 20. Now, because my median is a number in the set, I have to cross it out. And now I have my lower half and my upper half. So see how that's different when we have one middle number versus two middle numbers. With two middle numbers, we drew a line between where the median would be to break our set into two halves. For an odd number, we actually cross off that middle number there. Okay, so that's really important. Now I can find my median of the lower half. I have two middle numbers, 4 and 5. If I add them together and divide by 2, I get 4 and 5/10. Here I have two middle numbers, 14 and 15. If I add them together and divide by 2, I get 14 and 5/10. And I can plot them. Remember, the minimum gets a dot. Here's my dot. I counted by 2's on my number line this time because my data was closer together. My maximum is 20. That also gets a dot. And my 3 quartiles get plotted with vertical lines. So 4.5 is right about here. 8 and 14.5 is right about there. Now I can connect my tops, connect my bottoms. There's my box. Connect the whiskers. And now I've got my box and whisker plot. The IQR, 14.5 minus 4.5, that's down here. My IQR is 10. So that means 10 data points sit inside the box. And I do have a couple questions we can answer together really quickly. What percent of the data lies between 2 and 7? So 2 and 7, well, that's right here in this section. That's going to be 2 of my 25% chunks. So that's going to be 25% plus 25% is 50%. What percent of the data lies between 14.5 and 20? So here's my 14.5 and 20. That's 1 quartile, so that's 25% of the data. And what percent of the data lies between 4.5 and 20? That's 1 quartile, 2 quartiles, 3 quartiles. So that's 3 times 25, which is 75% of the data. So remember, a quartile represents 25%. That's a big idea for us in this lesson. Okay. Last but not least, why do we use box and whisker plots? They analyze large groups of data, breaking it into quartiles. They look for the spread of the data. So short quartiles means the data is close together. Long quartiles means the data is more spread out. And helps us look for those types of trends. Again, if we go back here, we can see that we've got one long quartile. That data was pretty spread out. This is a shorter quartile. That means the data is pretty close together. All right. That's it for box and whisker plots.